For years, the AI world assumed more agents equal more intelligence. This paper proves that's a myth. Google's new scaling law shows why adding more AI agents might make your app or workflow worse. Google tested 180 different AI agent setups in a rigorous study and found that adding more agents actually degrades performance by 40 to 70% on sequential tasks like complex coding or planning, but boosts performance by 80% on parallel tasks like data analysis. They also went further to provide a scaling law formula so developers can predict exactly when to use a single agent versus a swarm of agents. Hi, if you're new to this channel, welcome. My name is Mariam and I discuss the most important updates in AI, machine learning, and natural language processing based on more than a decade of my experience in this field. While I was away from the channel, I was planning an agentic project with a complex multi-agent system build. I found it to be quite messy and slow and expensive, and it kept hallucinating. So I researched around for a solution and I realized that Google has already found the culprit. It was such a timely result that I decided to make a video about it and share these super important findings with you. The joint Google and MIT research team recently dropped a paper called Towards a Science of Scaling Agent Systems, and it's a massive reality check. They have actually derived a mathematical scaling law for agents. They tested 180 different agentic systems and revealed that for most of the tasks we are building, adding more agents isn't making the AI smarter. It's making it dumber. It's actually making it hit a capability saturation point where it starts to fail. That explains why my project was behaving weird, and probably yours too. But don't panic, because I'm going to break down the math of why your agentic workflow is probably failing in super simple language and share the 3 specific rules Google found for when a swarm or a multi-agent system actually works. Check out the links to see more results. But before we look at the math, we need to define our players. We have SAS or single agent system. This is where we have one model, one prompt, and one goal, just like a solo developer. Then we have MAS or multi-agent system. Google's research divided into 4 groups of independent or no talking, centralized with a manager agent, decentralized, which is peer-to-peer or all agents talking to each other, and hybrid, which is an orchestrator plus limited peer-to-peer. Here's the main theme of the paper. Most people assume a MAS will always beat a SAS. Google found that's dangerously wrong, and they specify 3 reasons for it. Let's talk about the first point, capability saturation. According to their 45% threshold rule, once a single agent reaches around 45% accuracy on a task, adding more agents to collaborate actually leads to diminishing or negative returns because the communication overhead outweighs the help. In simple terms, the agents spend more time misunderstanding each other than they do solving the problem. The takeaway message from this point is, if your LLM is already smart enough for the task, keep it simple. Don't build a swarm for a task a single model can do alone. Now, let's turn to the second important reason, the relay race problem. Every time you pass the baton or data, there is a chance of a drop or hallucination. They discussed this under task complexity and information gain. This is where you have to choose between parallel and sequential agentic tasks. Google's research found that for parallel tasks like checking 10 different product prices at once, MAS is a beast with an improved performance by more than 80%. The bad news is that for sequential tasks where agent B needs agent A's output to start, MAS is a disaster. Performance dropped by 40 to 70%. The last reason, which is a bit scary for developers, is error amplification. Google found that independent agents just throwing them at a problem amplify errors 17 times the baseline, while a centralized or manager type architecture keeps it to only 4 times. Their takeaway message is that in a swarm of agents, the errors don't add up, they actually multiply. All these disappointing findings about multi-agent systems don't mean you cannot use them again. Here are what this paper is suggesting for best results if you decide to incorporate multiple agents. First, centralized is king. Google found that having a manager agent or a centralized architecture is significantly better than letting agents talk freely, for example, in decentralized agentic systems. And also because in centralized multi-agent systems, error amplification were kept at minimum. The Google's scaling law that I talked about earlier, in simple terms, boils down to this. Your success depends on the number of agents, the structure, the model's base power, and the task type. Don't build a complex swarm because it looks cool on your social media profile. Build it only if your task is parallel and your single agent is struggling. Sometimes less is more is the most advanced AI strategy there is.